Hello once again, ladies and gentlemen, and welcome back. We are on our last question, question 25 of the 2016 Gauss paper, the grade 7 Gauss paper. Although, if you're looking for more Gauss papers, the grade 8 Gauss is the natural follow-up, so feel free to look around for the 2016 grade 8 Gauss. Okay? So, what does question 25 have in store for us? In the triangle shown, the first diagonal line, 1, 2, 3, 4, and so on, begins at 1, and each number after is 1 larger than the previous. So there we go, there's our first diagonal line. The second diagonal line, 2, 4, 6, 8, begins at 2, and each number after is 2 larger than the previous. And then the next goes to 3, goes up by 3s each time, 4s, 5s, 6s. Okay, I understand. The nth diagonal line begins at n, and each number after the first is n larger than the previous number. In which horizontal row does the number 2016 first appear? Okay. So, when do numbers appear, and how early do they appear? And if I erase all my sort of scratchings here, I think a really good candidate for this might be the number 6. I'm seeing a lot of 6s here. Okay? But the first time 6 appears is in this 1, 2, 3, 4th row. Why does the 6 appear there, and why isn't the first appearance of the 6 down here? Okay. So we have to sort of ask ourselves, well, why do certain numbers appear where they do? Okay? If we think about the diagonals they appear in, the 6 appears in the first diagonal, the second diagonal, the third, not the 4th or the 5th, at least not that we can see. Although since we hit 12 and 10 and these are much bigger than 6 and the number's are only going to keep getting bigger, I think it's safe to say the 6 won't appear there. But the 6 does appear down here in the 6th column. Or not 6th column, 6th diagonal. Okay? In fact, based on their definition, the numbers in the nth column, or nth diagonal, I don't know why I keep calling them columns. So the numbers in the nth diagonal are all the multiples of n. So if I want to look for a number like 6, what diagonals might it appear in? It has to be sort of a base number, like 1, 2, 3, or 6, that is a factor of 6. Okay. So the number, and I can be kind of general here, the number, let's say, m, appears only in the diagonals numbered by factors of m. So, for example, something like 5 should only appear in the first and 5th diagonal. Something like 12 should appear in the, 12 should appear in the 1st, 2nd, 3rd, 4th, 6th, and 12th diagonals. Okay? We can already see a little bit of evidence of this. I see a 12 here in the 4th diagonal and a 12 here in the 3rd diagonal. The next one after this 6 should be a 12 over here. And actually after this 10, I should get a 12 down here. So they really are appearing in the 4th, 5th, 2nd, 6th, and then there'll be another 12 all the way down here at the same height as the 12 from the first column. So that tells me what diagonals I might find the 2016 in, or at least that gives me a good start. But now, what about the horizontal row? Alright. So why do certain numbers appear at certain heights? Why do we have 2 6s in that 4th row? Well, once in a diagonal, let's say this. So once we, let's use our sort of generic number m, because there's nothing special about 2016. It just happens to be the year. Okay. So if I said something like m, my capital letter, is equal to AB, then m will be in the 8th diagonal which starts, it starts A, and then it goes 2A, then 3A. So the third entry in a diagonal is just 3 times whatever diagonal you're at. So it'll go all the way down to B times A, which is equal to my number M. So the bth value in the 8th diagonal is A times B. Okay, so that's sort of a nice little rule. So now if I'm looking at 2016 and I know it appears in the second row, I know it'll have to appear in the 1008th position. Okay. So is there anything else we sort of need? Well, these diagonals start at different rows. So, for example, the 8th diagonal starts in row A. So 2A is in row A plus 1. It's the next entry in my diagonal, so it's 1 row down. 3A will be in row A plus 2. And so 4A will be the next row down. So it'll be in row A plus 3. And so you might see, oh, I can see how the 2, 3, and the 4 are turning into 1, 2, and 3. So BA will be in row A plus B, and then we subtract 1. So let me see if I've got this right. So 6 has factors 1, 2, 3, and 6. Those are the only factors of 6. So 6 will appear in diagonals 1, 2, 3, and 6. 6 is equal to 1 times 6. And so in the first diagonal, it will appear in row 1 plus 6 minus 1. 6 is also equal to 2 times 3, so it'll appear in the second diagonal, and it'll be row 2 plus 3 minus 1. So that's row 6. This is row 4. Well, hey, 6 did appear in row 4. So it looks like my theory is working out. 6 coming from the third diagonal will be in row 3 plus 2 minus 1. Again, 4. That's why we have 2 6s in row 4. And finally, the 6 coming from the sixth diagonal will appear in row 6 plus 1. The rest of what I need to make a full 6. Subtract 1, so row 6. And if we look, we've got 2 6s in row 4, and we've got 2 6s in row 6. So everything's working together, and everything, all my understanding is combining, and it looks like it really reflects how this triangle works. Now you'll notice I didn't jump straight for the 2016. I was puttering around with things like 6, I mentioned 5, 12 even. Smaller numbers that help me get a handle on a very, very big thing, because I don't want to write out this whole triangle. Even if you gave me an hour, I don't think I could write out enough of it to make 2016 appear. Maybe if I was really trying to race my way through it. So by looking at smaller cases and understanding how the triangle's put together, I can make bigger deductions. So now, to find the earliest 2016 will appear, I just need to look at its factors and sort of factor it into pairs, and then add those pairs and subtract 1. So 2016, let's see, that has 2 times 1008. So that's 2 times 2 times 504. So that's 2 times 2 times... 504 is 7 times 8 times 9. You could factor this a little easier if you had a calculator. So that's what? 2 to the power of 5 times 3 squared times 7. I guess to the power 1 if you want to. Now that's going to be a lot of factors of 2016. I suppose I could try them all. But, well, We want 2016 to equal to A times B, and we want A plus B minus 1 to be as small as possible. We just want the first entry, so the earliest entry, the lowest horizontal row. So we want A plus B minus 1 to be small. So I could work out all the possibilities. There'll be 36 different possible combinations. But some things like 2016 times 1 or 1008 times 2 are so wildly out of the way. I mean, look at our possible answers. We're not even close to 2017 or 2000 or 1009 as a possible answer. So we can definitely get rid of those. How can we factor 2016 and try and keep A plus B minus 1 as small as possible? Well, it turns out there's a nice little trick. If you've got two factors and you want their sum, we want their sum minus 1. But if you want their sum to be as small as possible, you want A and B to be as close in value as possible. So it's a nice little trick if you haven't seen it before. Now I'm passing it on to you. So to minimize A plus B minus 1, make A and B as close in value as possible. Just like if we wanted to maximize A plus B, you'd make A and B as far away as possible. So 2016 and 1. Close in value as possible. Well, the closest they could ever be is if they were actually equal. Now, unfortunately, 2016 is not a perfect square. But if you did, 2016 times square root of 2016 plus square root of 2016 is as small as you can make two numbers that multiply to 2016. Now, 2016 is really close to, I'm pretending I don't have my calculator here. Okay? 2016 is really close to 2025, which happens to be 45 squared. So 2016, square root of 2016 is about 44. Okay? Can I think of factors of 2016 that are close to 44? Well, what have I got? I need to have a multiple of 7 here. So can I think of multiples of 7 that are close to 45? Well, yeah, 42 is pretty close. So that's 7. That takes care of one of the 1s, and it takes care of one of the 2s. What's left over? 2 to the power of 4, and then another 3. So that would be 16 times 3, 48. I don't think we can get any closer than that. I mean, they're pretty close. You have to have a multiple of 7. I suppose maybe we could do 49. No, actually, you can't do 49 because we don't have enough 7s. So this really had best be the answer. Okay, so 42 and 48. All right. So what's that going to mean? So I'll let my A be 42. I let my B be 48. And what's the row that I'm going to find 2016 in? 42 plus 48 minus 1. So that'll be 90 minus 1. And so that'll be 89. Is 89 one of my possible answers? Absolutely it is. And the only thing smaller is 88. So I'm confident that I haven't missed anything out and that E is, in fact, the right answer. Okay. So there we go. E is our answer, and that wraps up the whole 2016 Grade 7 Gauss. It's been a nice little paper for the most part. I'm eager to see what the 2016 Grade 8 Gauss has in store, and I'll be starting that in the future. Until then, take care, thanks for watching, and have yourself a wonderful day.